Question number 31. The product formed in the following thermal reaction is. You see, this is a Fry's rearrangement of thermal reaction. Option is C. Next question. Match the following. Question number 32. First one, Dickman condensation. In Dickman condensation, a carbon ion was formed. Second, in Friedel-Crafts alkylation, carbocation was formed. You match the reaction with the intermediate formed. Okay. In Hoffman rearrangement, you will get nitrene as an intermediate, reactive intermediate. In Reimer-Tiemann reaction, you will get carbene as a reactant intermediate. So you have to match the name reactions with their intermediate formed. So here option B was correct. Question number 33. In the given reaction, the product X was. Now you take this product. Now you take the reactant. Here option A is correct. Now the effective transformation of acetophenone into ethyl benzene can be achieved by. Here acetophenone, the carbonyl compound C double bond O was reduced to CH2. The C double bond O of acetophenone was reduced to CH2. This was achieved by Clemmensen reduction and Wolff-Fishner reduction and Mozingo reduction, not Rosenman reduction. So option A was correct. Here you see 3-ethyl 5-phenylpentene in acidic medium rearranges to. So this is a compound 3-ethyl 5-phenylpentene is a compound. Here this double bond shifts here and again this double bond shift here. This so again you will shift here. You will get a 5-membered ring, not a 6-membered ring. You will get a 5-membered ring here. It's a 5-membered ring, and you will get this 2-methyl group CH2CH3, CH2CH3. So here option C was correct. Here in option B, a 6-membered ring has been formed, or is ruled out. Option D also 6-membered ring has formed, and in option A this was ruled out because this product was not formed. Option C was correct. In the reaction, this benzene reacts with bromine in ion. Again it reacts with Me, trimethyl chloride, AlCl3, and again bromine ion. You will get a dibromo compound. So para dibromo benzene. So option D is correct. Question number 37. The conversion of orthonitroaniline into orthodinitrobenzene is carried out by. What was the reagent used here? This was orthonitroaniline was given. Orthonitroaniline. This orthonitro compound was converted into, here you see this NH2 was converted into NO2. That is orthodinitrobenzene. Okay. What was the reagent here used? Here you see the peroxo compound was used here for this oxidation. So here this was not an peroxide. Option A was ruled out. Option B is an oxidizing agent but not an peroxide. So option D was ruled out. Option B is correct. CF3CO3H. the precursor for biosynthesis of quinine and papaverine, or the precursor complex that is used for the synthesis of quinine and papaverine. This is a papaverine structure and is a quinine structure. Here you see we are using two compounds. For this is tryptophan and tyrosine. These two compounds were taken for the synthesis of this compound. Tryptophan was taken for the synthesis of papaverine and tyrosine was taken for the synthesis of quinine. And option C is correct. Tryptophan and tyrosine. The structure of histidine predominantly exists at a physiological pH 7.3 is. Here you see the pH value was given as 7.3, which was nearly equal to neutral. This pH value 7.3 will appear when a zwitterion was formed. Here in option A you see there was no zwitterion. Option B, a zwitterion was formed. Here in option A, this zwitterion formed, but the plus charge was present here. So option A was ruled out. In option C, the plus charge was here and there was no charge here. So option C was also ruled out. The pH will not be equal to 7.3. Here in option D, there was no charge in COO minus. There was no zwitterion was formed in option D. Is also ruled out. And option B, there formed an zwitterion COO minus and NH3 plus. Zwitterion means the compound has both positive charge and negative charge. Zwitter means 2. One is positive charge and another one is negative charge. It is called zwitterion. So this zwitterion, if exists, means the pH will be nearly equal to 7. So option B is correct. Question number 40. You see the compound was given. In presence of lead acetate, it will rearrange as to compound. Option A is correct. It's a simple photochemical reaction. The reaction of tetrahydrofuran with 2 moles of trimethylsilyl iodide yields what is the product? Here you see this is tetrahydrofuran reacts with trimethylsilyl iodide TMSI. You will get the bond will be broken, it will be reduced to, and you will get this 1,4 diiodobutane. Option D was correct. It gives the product. The product formed in the following reaction. You see this is an Barton reaction. In Barton reaction you will have this splits into Bu3SN. You will have a radical here. This one radical and this one radical. This hydrogen combines with bromine to give HBr. This bromine will be left out, and this Bu3SN combines here, combines in place of bromine and rearranges to give option B. It's a simple Barton reaction, and this one is also another form of Barton reaction where PPH3 4 times and you are adding carbonyl compound CO in presence of ether. Here this iodine leaves and this Bu3SN adds here. In between CO will be added. Option C is correct. Here you add C, this C double bond O. Here, this match the following. Question number 44. Match the following. Mefensin drug was used as a muscle relaxant. Ibuprofen. Ibuprofen is nothing but an anti-inflammatory agent. It's an anti-inflammatory agent. And third one, albuterol is used as an bronchodilating agent. And fourth one, omeprazole. Omeprazole, you all know that is used. This drug was used to cure cancer. It's an anti-ulcer drug. Sorry, not cancer. It is ulcer. For ulcer patient, we are giving omeprazole. Okay. Question number 45. In the reaction X formed, the product formed. Here you see KSCN, this K plus and SCN minus. This SCN minus adds here, and the bond will be broken, and the sulfur is directly bonded to give the product A. A is the product. So we will meet in the next video, that is part 3.